Okay, today I'm going to introduce you to a new mathematical number at e. So what is e? E is an irrational number. An irrational number is a number that does not terminate or repeat. So you cannot write it as a fraction. And mathematical e, is the number 2.71828. It goes on and on forever. And we're going to estimate it at about 2.71. So let's look at the exponential graph with a base of e. So again, this base of e is about approximately 2.71. So if we think about plugging in numbers to make our graph, again, easy numbers are from -2 to 2. Let's start with the easy one. Let's plug in 0. E to the 0, anything to the 0 is 1. So it is going to go through 0, 1. If we plug in 1, e to the first is going to be about 2.71. So almost to 3. If we plug in 2, we're going to get about e squared, so 7.389. So what about -1? E to the -1 is 1 over e, so about 0.368. And if I plug in 1 over e squared, that's about 0.135. So e to the x, again, it is exponential. It has that kind of backwards L shape. If we think about, again, I call parent function the play-Jane function. What are some key attributes? Notice our domain. Our domain is going to be all real numbers, just like with all exponentials. I can plug in any positive x. I can plug in any negative x. Now notice my range is not infinite, because this graph is getting closer, closer, closer to the x-axis, but it's ever not actually going to cross it, because we do have an asymptote. That is the x-axis, i.e. a horizontal line. Horizontal lines cross the y-axis, so they are y equals 0. So that restricts our range. So our range, it can't be 0. It's going to get really, really close and everything above. So again, this is for plain Jane function. If I just have basic y equals e to the x. Nothing added, nothing multiplied, subtracted, etc. So what is the inverse of e? How do I undo an e? Well, how do I undo an e is what's called the natural log. Okay, it's called the natural log. So if I take log base e, I have a special name for log base e. A log base e is how we can simplify as ln. So ln of x, this automatically denotes that I have a base of e. So let's look at the graph of a natural log of x. So again, what I call the parent function, plain Jane function. And again, all the natural log is that it has a very special base, a base of e. So just like when we have log and we don't have a number, defaults to 10, ln natural log automatically defaults to base e. So if we plug in some easy numbers, and again, natural log is a button on your calculator, it is an operation. So if we plug in some easy numbers, if we plug in a natural log of 1, we will get 0. So we have 1, 0. If we plug in 2, natural log of 2 is going to be the decimal about 0.69. And if we plug in 3, we get about 1.09. But notice what happens when we plug in 0. If you try to plug in 0, you are going to get undefined. So why are we going to get undefined? Natural log is a log. Okay, it's just a special kind of log. So it does have a vertical asymptote at the y-axis. So notice my graph is going to be kind of that R shape. It's going to go down to negative infinity, get closer and closer to that y-axis and never cross it, and then slowly increase on the right-hand side. So key attributes of your parent function, natural log of x. Well, domain, remember, because these are inverses, if the range is 0 to infinity for base e to the x, natural log's domain is going to be the same, 0 to infinity. Domain and range switches for inverse functions. Now notice my range is infinite, negative infinity to infinity. And just like normal logs have a vertical asymptote, the natural log has a vertical asymptote as well. And vertical lines cross the x-axis. So asymptote starts at x equals 0 for our plain Jane natural log. Nothing added, nothing subtracted, nothing multiplied or divided. Okay, so introduce you to two new functions, e to the x and natural log. Now, both of these have exactly the same properties as exponentials and logs. I can still use my product property. I can still use my quotient property. I can still apply my transformation rules. So let's do a little bit of practice, making sure that we can apply all of those rules as well. Transformations. Okay, so let's start with exponential. Can we describe how the graph is going to change? From our plain Jane, just e to the x function. So we always start outside. Outside is up or down. So since it's a -3, it's going to be moved down 3. Inside, think opposite. So inside means inside the exponent is left or right. So +2, think opposite. It's going to be moving left 2. And multiplying on the outside is going to be a vertical stretch or compression because I have 1/3. I'm getting smaller, right, if I multiply by 1/3. So this is going to be a vertical compression. And again, think about graphically what a compression is going to do. If you compress your head down, right, your volume is going to go out. So you're going to get a wider, flatter graph. You're going to get a wider, flatter graph. So again, you can put that in your calculator to see exactly what the graph is going to look like. But if you just want to draw a quick sketch, okay, turn those brains into graphing calculators. Typically, e to the x, we have an asymptote at the x-axis. Well, since we're moved down 3, that asymptote is going to be moved down 3. And typically we would go through the point 0, 1, but we're moving down 1, 2, 3, and to the left 2. So that initial point should be here. And because we are vertically compressing, it's going to be a little flatter graph, so it's not going to quite go as steep. Be a little flatter. So again, verify. This is just a very rough sketch. You can graph on your calculator to find precise. But vertical asymptote will be at y equals -3 for your asymptote. And remember, if your asymptote changes for exponential, then your range would change. Your range would be from -3 to infinity. So let's practice a natural log one. So what if we have a y equals 2 natural log x minus 2 plus 1. So again, your transformation rules still apply. Whatever's outside the parentheses here, outside the natural log, moves it up or down. So since it's +1, it's going to be moved up 1. Inside, think opposite. So here, inside the parentheses of the natural log, we're moving left or right, but -2 is going to move it right 2. And we're multiplying on the outside. 2 is greater than 1, so we are vertically stretching. So think about if you vertically stretch your body, you're going to get a taller, skinnier, steeper graph. So again, you can graph, turn your brain into a graphing calculator, draw a quick sketch. Typically, natural logs have a vertical asymptote at x equals 0, but I am moving it right 2. So my vertical asymptote is going to be moved right 2. Typically, we would go through the point 1, 0. But since we're moving it right 2 and up 1, it will be going through the point 3, 1. And again, we go towards the asymptote on the left-hand side. And vertical stretch, too, means that we're going to be slightly getting a steeper graph. So it's going to go up a little bit more. Again, you can graph it on your calculator to find exact. But key features, your asymptote. Your asymptote would be a vertical line, x equal 2. Again, which restricts your domain. So your domain would be from parenthesis 2 to infinity. Okay, so last thing I'm going to show you is that all of your properties of logs still apply to a natural log and base e. Okay, practice simplifying to make sure that we can still utilize all those properties. So if we need to simplify e to the natural log 7. So again, remember that e and natural log, they are inverses of each other. If I have e raised to natural log, these are inverses. They will cancel. We're just left with the exponent. If I have natural log 7 plus 2 natural log 5. Okay, my first step is that I can move the 2 in front, remember, is the exponent. So I have natural log of 7 plus natural log of 5 squared. Well, what is 5 squared? 5 squared is 25. And then I have natural log plus natural log. Remember that we have, when we have addition rule, that means we can multiply. So I can take natural log of 7 times 25. And if you multiply that out, we get natural log of 175. So exact answer would be natural log of 175. Again, you could put that in your calculator to find the approximated decimal answer if it asks. Okay, so log properties are all used similarly, which means that we can actually solve using those log properties as well. Oops, we're on number 5. So what if I have natural log 2x plus natural log of 3 equals 2, and I need to solve for x? Well, here we know that if we have a natural log plus a natural log, addition means I can simplify using multiplication. So natural log of the first, 2x, times natural log of the second one, which is 3. Well, what is 2x times 3? That is 6x. Well, I'm stuck. I need to solve for x. It's in the natural log. Well, this just means that we need to change to exponential. So remember, natural log has a base of e. So we can take e, square it, and that's going to equal 6x. So again, natural log doesn't have a base. It does have a base. Its base is e. So e squared equals 6x. Divide both sides by 6. And the exact answer would be e squared over 6. Remember, e is a mathematical number about 2.71. You can put in your calculator to find the estimated answer, but the exact answer would be e squared divided by 6. So same rules apply. Just know that natural log has a base of e if you need to change it to exponential form. So last one, solving. If we have 4e to the 2x plus 2 equals 16. 4e to the 2x plus 2 equals 16. Well, first step is I need to try to isolate the e to the 2x, so let's subtract 2 from both sides. We can divide both sides by 4. If we simplify, these both can be divided by 2, so this is 7/2. Well, I'm stuck. I need to solve for x, right? Well, x is in the exponent. How do we get it out of the exponent? We need to change to natural log. So change to natural log. So again, natural log has same properties of log. I have natural log of what? My base is already e. Of the right-hand side, 7/2. That equals the exponent of 2x. Again, you can always think with your circle to double check. And now that I have the x out of the exponent, I simply can divide both sides by 2. And the exact answer will be this half you can pull out in the front, 1/2 natural log of 7/2. And again, if you need the approximated decimal answer, you can put that in your calculator. Okay, so introducing you to a new mathematical number e is the decimal approximately 2.71. The inverse of e is what we call the natural log, ln, and that's just a special log with base of e.